Good morning. Today we're looking at chapter 11. This is the first section in chapter 11, and that chapter is all about circles. These are our objectives today. We're going to try to solve for tangent lengths on circles, and I'll explain what that is in a minute. There's all sorts of different things you can do with circles. Some of them are listed here. And you've got an IXL later on where you're going to try to get at least an 85. Couple of definitions you'll need for today's lesson. A line of tangency. It intersects a circle at exactly one point. And a point of tangency is that point. It's where the line of tangency kind of brushes against the circle. So if it hits at only one point, it means it just barely brushes against the side of it, just like you see here. So the first theorem we know is that if a line is tangent to a circle, then that line is perpendicular to the radius. So you see right here, you've got a radius. This is circle C, with C being the center point, and the point of tangency is at P here. These two lines will make a right angle. So that's the thing that's always going to happen. Anytime you got a line of tangency, if you connect it to a radius at the point of tangency, you get a 90-degree angle. All right, the converse just says that if you know a line is perpendicular to a radius at that radius's endpoint, then it's going to be tangent to the circle. And here's how that line might look. If I just come in here and give myself another line that is a perpendicular, I know that's also going to be not only a perpendicular, but a line of tangency. So if it's a perpendicular, I'll have a box. And it would look basically the same as the other. It's just saying that this theorem goes in both directions. All right, so how can we actually solve using this? They want to know the radius in this question. Well, I know that I've got a box here because I got this point of tangency. So that means I can do a Pythagorean theorem. So r squared plus 15 squared ought to equal 17 squared. So at that point, it's just a matter of doing 17 squared minus 15 squared. And I'll go to the calculator real quick and see if I can't establish what that is. It's 64. So 17 squared minus 15 squared gives me 64. You can see that here. Well, that means r squared is 64, which means r must be 8. So it turns out we have a radius of 8 here. So we have an 8, 15, 17 right triangle and a radius of 8. And we can solve that because we know it's a right angle and therefore it's a right triangle. All right, this question wants to know if segment BC is a tangent to circle A. Well, that just comes down to, do we have a right triangle here? So is this angle here a box? Is it appropriate to put a box there? Is it actually a 90-degree angle? Well, is 8 squared plus 14 squared equal to 19 squared? If it is, then I have a right angle. Let's look at our calculator. I already calculated this one ahead of time. 8 squared plus 14 squared is 260. 19 squared is 361, so no, it's not even all that close. This is not a right angle, and so it is not tangent. So no. And that's all based on 8 squared plus 14 squared not equaling 19 squared. All right, here's another type of question. They want to know if these are tangents to the circle, what is angle B? So you see the X out here. Well, because we know they're tangents, we know these are 90s. And if you look closely, what we've got is a four-sided figure. There's one radius is one of the sides, other radius is another side, so that's 2. Here's the third side, and then AB would be the fourth side. So this is a four-sided quadrilateral. It ought to have 360 degrees in it. So if we take our 360 and we subtract out these three angles, you got two 90s making 180 and 120, add all that together, you got 300, so X should be 60. And that's just knowing that there's a total of 360 degrees in here and subtracting out these guys, knowing that two angles marked in red are 90s. All right, a couple other vocabulary words. An inscribed polygon sits inside the circle with vertices on the circle like this one. Inscribed sits on the inside. Not surprising. Circumscribing, you see circum, you think about going around something. So circumscribed is the polygon that's on the outside of the circle with each side tangent. So in this case, the circle is inside, the polygon is around it. All right, here's another theorem for you. You've got two segments tangent to a circle from a point outside of the circle, and they are always going to be congruent. So if you want to pause it, if you like jotting down theorems, some of you like to write them down in your notes, you can always pause this video for a minute if you need it. These are also in the book in section 11.1. So these two marks just showing that AB is congruent to BC, that's going to be true anytime you have two tangent segments. And this, when it says it's congruent, that's stopping at point A and point C. It's talking about AB and BC being congruent. If you come from an external point like B, you go to the point of tangency, that segment's going to be the same as it would be if you went to the other point of tangency, because there's two from any external point. Using that theorem, I can say, okay, if this one up here is 8, then this one down here is 8 also. I can use that to find the perimeter. So for example, if this one here was 8, then I've got an 8 over here as well. And if this one here is 4, then I've got a 4 over here as well. 2 means that I'm going to have a 2 on the other line of tangency. And a 5 from this point down here would mean I'm going to have a 5 over here also. So if I want to know the perimeter, now it's just a matter of adding up all the pieces. I got a couple of 5s that makes 10, plus a couple of 8s that's 16, so that's 26 total. Plus 8 over here makes 34, plus 4 makes 38, so this is a perimeter of 38. You're going to have to do some stuff like this on your IXL. Okay, so here's one that's a little trickier, but not too bad. Because this one is 8, I know this one is 8. Fill that in red here. And I know the total of this whole side of the polygon is 12, so that must be a 4 over here, because 8 plus 4 makes 12. And then, now that I've got the 4 here, I can get onto this one and say that this must be 4. And if this is 4 and the total is 10, then I can get 6, and you probably see where this is going. I'm going to fill in another 6 here. And then a 6 adds with a 9 to make a 15. And now I've worked all the way around to figure out this x, which is 9. Because it's got to match. Because this one is a 9 coming from this external point, and the other line of tangency would also be a 9. So I found the x, which is 9. I guess that's what this problem wanted. You could also get the perimeter if you like, because you can add them all up. All right, the IXL you do is U.8 today, and I would like to see a score of at least 80 for full credit. So 80 equals 4 out of 4. Spend half the video writing this. 4 out of 4 full credit if you get an 80. So please take the IXL seriously. Spend your time in class first getting at least an 80 on U.8. Get a little farther if you can. And then your homework over the weekend is going to be this, page 586. All of these problems listed here. So please make sure that gets done for when you come back on Monday. And hopefully by then I will be healthy and so will my kids, and I will be back in school. Have a nice weekend, and I will talk to you when I get back.